Okay, hello everyone. I would like to introduce myself. My name is Tariq El-Dakruri, and today will be a very interesting topic we're going to be talking about. It's not just a lecture, but it's more of a research paper that we have implemented, and the results, we're going to be discussing it and the effects of it. So this paper has been written not just only by me, but also Dr. Idib. He is the head of the computer engineering department. And we found a very nice results for the impact of robotics on the economy right now. So before we go further, let's talk about the obvious. Right now, everyone is implementing ChatGPT in their life. So it's like your personal assistant. And imagine having your personal assistant with you 24/7. So this is the impact of the future right now. So it's not only artificial intelligence is our most important thing that is happening in our daily life, but imagine implementing that into a humanoid or something that could be doing a human job. So how will this impact the economy in a positive or a negative way? We're going to be discussing more about this, and the research paper is more focused on that. And let's go further. So, why robotics and employment? So look at this from this perspective. Right now, everything that used to be virtual has been replaced by artificial intelligence. But what if we can replace real human beings with robots? Will it have positive impact, or it will have a negative impact? And which economy will be able to handle this in the most efficient way, or the positive way out of it? So I can see right now, and the chart appears on the right, there is in the total in 2022, there was about 50,000 new units of robots being implemented globally. But regarding, you can see in the graph, we have 2008 until 2018. So 10 years period, and it shows which country has the highest implementation. And you can see over here, Asia and Australia has the highest implementation of robots into the industrial world. How does this positive? We were going to be talking about it in the upcoming. But the most important thing is that will it improve the outcome? So if we brought robots to basically replace the normal labor, the low-skilled labor, will this be a positive thing? We don't know. We're going to know right now. And does the policy of it, making it fair for the human beings in our society, in our world right now, we're going to be discussing also about it and know exactly what's going to happen. But before we go, or go to the next slide, as you can see right now, the implementation between 10 years has increased significantly when it comes to Asia, because they are the highest production countries, and they have lots of labor, and that costs much. So imagine replacing this amount of labor just only by robots. All right. So, first thing we're going to be talking about regional disparities. So what does that mean? Oh, simple as that. How much an economy could beneficial or benefit from implementing robots? It's different in each country. You cannot have the same results in every country. You have high developed countries and you have low developed countries, and each one of them have its own effects. So the effects on a high developed country comes in a positive, and the effects of low emerging economy, but yet it is emerging, also have some sort of positive. But the third world countries are being affected despite what's happening. So there are solutions for that. Also, we're going to be discussing about it in the upcoming. And wage polarization, basically, the gap between high-skilled and low-skilled. There is going to be a huge difference. There are multiple types of skills. We're going to be going to the next slide and talking about it. And we're going to understand who are these people and what they fulfill. And finally, is the policy relevance. So, every country needs to have some sort of policy of implementing robots. You cannot just come and replace human beings out of a sudden. You need to keep in mind that these are human beings that have lives, and you have to keep in mind that doing that may positive the factory, but it has some sort of effect to the human beings that are actually working in that factory. But beside that, every government needs to implement some sort of policy to not lose, or basically low-skilled people to lose their jobs, basically. So, what was our research and how our research was done? We got the robots, the number of robots being implemented in 35 countries between the year of 1999 and 2014 in advanced and emerging countries. And then we used something called the fixed effect regression. It's a type of formula that we have alternated to use it to calculate the positive effects or the, how do you say, productivity out of it, and the policy insights, so reskilling and everything. So the formula as followed. Here you can see robots. After calculating the robots, we'll see the outcome of the productivity. Is it increasing, decreasing? Is it positive? Is it negative? We're going to know about it. The job and wages. Keep in mind, when you have some sort of increasing of robots, will be new jobs implemented, or is going to be some loss of jobs? We're going to know about that. And the policy, which is very important. Not every country has a policy when it comes to implementation of robots, but it needs to be incited, it needs to be implemented, and some of them do implement. Okay, so we have something called the SBTC, which is the skill-based, or basically, skill-based technology change on technological, how do you say, disproportionately, and also benefits of the high skills, and the abstract of complements, the substitutive route manual labor, and the outcomes. So which one of them, and what does it mean if each one of them? So benefits on high-skilled workers. So we have high-skilled workers which are going to be benefiting the most regarding this outcome. These high-skilled workers are considered as the software developers or mechanical engineers. They're going to be benefiting the most. And the technological task that's going to be implemented, of course, the people that are going to be implemented that are actually the robotics engineer and the AI engineer, and all of these people are going to be benefiting out of this outcome, of course. And also assembly of line are going to be affected. And of course, the wages level is going to be totally affected by the outcome of implementation to robots. This is only effects on labor side, but if you look at it from the bigger picture, it has also a huge impact to the economy. So, base task, okay, so the task-based model of the automation. What's the benefit of automation robots? Automated robots, or automation stands for robots that are capable to be autonomous. So, what jobs can robots replace? And what jobs robot may replace? And what jobs robots cannot replace, to be the more precise? So, routine versus non-routinish. Routinish jobs are the jobs that are basically same task, same thing, every day, nothing different, nothing being changed, same position, same location, nothing has to move from further your own radius, some sort of. So this is the routine. Non-routinous, that means you're going to be needing some sort of artistic way. You can see, of course, I have a video here I'll be playing, which is some sort of Kulkan robot creating some sculpture. So basically what I'm trying to say here, as you can see, this is non-routinish robot. But the thing is that the person who actually programmed this is a high-skilled worker, not just a normal worker, not just a low labor. Also, who used to create these sculptures are not considered as low labor, they're considered as mid-skilled workers. These skilled workers are highly neglected because we're going to be talking about the type of skills in 3 types of variation, which is the high-skilled, the mid-skilled, and the low-skilled workers. And each one of them are having their own priority. But the mostly neglected is the mid-workers because they are in the between of going on further or being dropped out by the robots. So, as we can see, the robots, as the research has implemented, has successfully created and has excelled basically in routine tasks. Boxing, creating some boxes, water bottles fill up, cans fill up, used to be done by normal human being labor, but right now robots are replacing it. So we do not need normal labor. Okay, so of course the final part, it talks about the human retains the non-routine-ish roles, which need some sort of different routine. But this is regarded what's implemented right now. We're not talking about AI having its own effect on robots, creating some sort of non-routine-ish jobs. Right now, there are companies, I'm not sure, I think so, yeah, Boston Dynamics have created some sort of robot that allows to create non-routine-ish tasks, moving objects from one place to another, using with the high tech, of course, and artificial intelligence allows it to do that. Are we in this age of right now being replaced by humanoids? Not sure, not 100%, for example. But regarding routine-ish tasks or routine-ish jobs are being replaced right now as we speaking by robots. So, excuse me. Okay. The skills, the level skills of workers. We have three main, it's a pyramid. The high, the mid, and the low. They're all types of skills. So who is the high workers or high level skilled workers? They are basically the robot engineer, the AI engineer, system designs. These are the high skilled workers. This is what are my students, most of them will be, hopefully. So we're finger crossed for that. And mid-skilled workers. So the mid-skilled workers are basically logistics and control quality or quality control. You cannot do that by a robot. Basically, these robots, before they leave the manufacturer to be replacing other skilled workers or low-skilled workers, they need to go through quality control, and these quality controls are the mid-skilled workers who are doing so. And of course, the logistics, some sort of transporting stuff from one place to another. Funny thing, logistics will be hopefully, not hopefully, but in the far future will be replaced by autonomous vehicles. And the cargo that is being kept on top of these robots also will be autonomously. So the robots will use the cargo, will take the items, keep it on top of the autonomous vehicle, and then will drop it later on. So that's why mid-skilled workers are not really highly, concentrated. People are neglecting them, but this is going to happen sooner or later. Of the, of course, pyramid of the skills. And the sadly one, which is also positively, and we are going to be talking about it, how can we avoid or work together to make economy work harder, be stronger, and not neglect any type of labor. So low-skilled workers are, of course, assembly, packaging, and so on. No need explanation, of course. All right. Employment effect by skill levels. So there are skills that we talked about them. There are wages that are being affected by that. So which skills are being affected? The low skilled the result came out after our research and obtaining public data. Negative 0.23 have been affected globally. And mid skills are negative 0.08. May sound like a small number, but it's still big if it's globally. Because mid-skills, as we said, it's the edge between skill and high, so it could be replaced or will be replaced in the far future. So then later on, the metrics will not be low, mid, and high, but it's going to be more of high and low. So the mid will be erased completely. So of course, the high, if you can see over here, high-skilled have positive out of that. The implementation of robot in the economy by 0.11. And look at the wages effect. Of course, those are low-skilled labor are being affected negative 0.41 as our results came out. Mid-skilled workers are negative 0.12. And then we have the high-skilled workers who positively got affected by 0.28, which is a high percentage, of course, because that means there has been job created, of course. So, as you can see in this diagram that is being presented right now, or figure to be more precise, we have some sort of wages increase to the high skill, and we have negative 0.41 of wages decline when it comes to low-skilled workers. So, this is a confirmed theory by the SBTC theory, and also the data has been collected from the IFR and the OECD. Of course, the IFR, most of our data has been obtained from IFR, which is the International Federation of Robots. This is where we understood, of course, and the OECD is more focused on the labor and wages. So we took their data, calculated using our formulas to see the outcome of implementation of robots within that year and the result that came out of that. Okay, so as you can see in front of you, of course, we have 0.41 negative in the negative for the low skills or the wages for them. And we have, of course, increase in the high skilled one. But when it comes to the mid skill, they have been affected, but they do not have been continuously affected because their jobs are not yet being replaced. They will be in the far future, but at the meantime, they're kind of safe. All right, annual installation of industrial robots by customer on industry or whatever. The point is, what we're trying to talk about here is that which type or specific section or sector is being implementing autonomous or robots, to be precise. Automotive is one of the highest, actually, and also electronics. They are the top highest sectors that are being replacing normal labor with robots. As you can see, the numbers are actually going very high from 2021 to 2023. This is the available, and the source is from the World Robotics Federation, where they have actually publicly announced these data in the 2024, which is last year. And you can see, of course, there are some sort of low increase, sudden high increase, and then reducing a bit. Of course, the point is let's talk about it from a different perspective. If you buy a very reliable robot and doesn't need high maintenance, doesn't need any sort of maintenance or cost, you don't need to buy more. But if it's getting damaged, of course, if it's getting, doesn't work out, you would need to get more. So the results are not highly, how you can say it in a very understanding way. So if the number decreases, does it mean that people are not, or companies are not implementing robots? They are, but they are not highly doing as they are fulfilled by the meantime. But also it's very important that by implementing so, you are doing some very positive effect to the economy, and also there are some sort of negative sides that comes out of it. The lowest implementation, you can see the food industry, and others we're going to be showing in a more detailed graph. All right, so why theory alone is not enough? We have Germany and we have China, okay? So this is very sensitive part. So the point is as follows. Germany have higher education, very strong education, trying to implement and trying to produce as much as high-skilled workers as possible. Rather than China, it's a big country, of course, they have high population, not, the whole country is not, of course, have higher education. They do have a huge percentage, but they do also have a bigger percentage when it comes to low-skilled labor. So look at it this way. If you implemented robots and these robots has some sort of positive effect for the economy, it will create high-skilled workers job opportunities. But if you have a high low-skilled workers and you implemented, of course, autonomous robots, it will affect very negatively on the economy because you will have thousands of jobless people who have been replaced by robots. So this is not a theory. This is something that is actually being implemented right now. This is something that is happening right now. So, is implementing robots a positive thing or a negative thing? As you can see, of course, by the increase of robots, there are about 0.8% of increase in productivity. So this makes us understand that implementing robots is some sort of positive way to grow productivity. If I have some sort of, let's say, industrial place that is producing or we're creating or packaging places, the robots will be capable of replacing labor, low-skilled labor, and they will not get tired, of course. I think so. My father have told me that. There is some sort of night factory where the robots are working in the dark. Of course, human labor need light, so reduce energy by turning off the light and let it run by itself. So you can see, of course, our research has proven that there is increase in productivity. And this is when it comes a little bit scientific. So forget about the 90% confidence. We'll talk about the p-value. The p-value is the value of trustable of source or income, or not income, sorry, source of output. So if our p-value, after we did our calculations, has increased the number, that is not very confident data. We are not 100% sure about that. But if the p-value is less, then actually we are highly trustable. We could agree together that this source, this result is 100% confirmed. Not 100%, I say 100% emphasizing what I'm trying to say, but that's what we're talking about. So in advanced economy, emerging market, and the global average. Advanced economy, of course, is like Germany. Emerging market, of course, is China. China will be one of the top emerging countries right now. And you can see, of course, the productivity have increased for advanced economy, 1.21, which is a very huge percentage. And also you can see the p-value is 0.008. So it means our calculations has some sort of, or high chances of confidence when it comes to that, this result. And globally, since we have obtained this public data and we did our calculation, the productivity has increased by 0.84. So our p-value is very, very low, which is 0.001, because of course this data has been public and we've used a formula. So we confirmed that this value has been, or the productivity is confirmed that it's been increasing due to implementation of robots. And of course, emerging markets or emerging countries, to be more precise, is 0.52, but our p-value is 0.032, which is some sort of still low, good, but we are not 100% sure if it will continue this way. All right. This is also a public data. Anyone could access it. Anyone could find it online. Robot density by countries, top and bottom, total of 5. So we have the top, and we have is from 1 to 2, then 3, and then we have the bottom one, which is 15 and 16. So the top one is South Korea. So for every 1,200 robot, it has replaced 10,000 workers, which is a huge, drastic change. But sadly, if you look at India, for example, by implementing only 12, it has replaced 10,000 robots. So looking at it from this perspective, you can see that high emerging countries with high educated people has some sort of positive effect. People has lost their job, of course, and this is in a sad news, but we're talking about economical effects. So it's a drastic, it's gonna happen. We should know about it, we should be prepared for it. And that's something is we're going through it in the far future, so we need to be ready for that. So you have, for example, Indonesia, by 8 robots being implemented, it has affected 10,000 robots. 10,000 workers, to be more correctly. And here you can see the GDP per capita. And but what I need to emphasize here right now is how is this a huge drastic effect? When you have low education, it has huge effect to the economy, of course. And when you try to develop as a country, you don't have the base to be able to build an emerging country. So when a country implements or emphasizes or spend more on education, this allows you, when you have some sort of a future implementation to your country, by implementing some sort of autonomous vehicles or implementing some sort of robots for industrial places, you can see the effect that is going to happen, but also as these robots are replacing some sort of low labor, you are increasing the job market for the high-skilled workers. And since the country is investing in education, so it means you will only have high-skilled workers. So implementing to the future will be a positive effect since the country has high-skilled workers. Of course, it's impossible to have a company with only high-skilled workers, but you will be reducing the number of low-skilled workers. So, as you can see over here, 1,014 robots implemented in South Korea, and it has replaced 10,000 workers, while in Germany, 429 robots implemented has affected 10,000 workers. Okay? So, yes, Germany is a first world country, but also some sort of implementation through robots actually provide us the information that we didn't know, that there are some sort of high level of low-skilled workers in Germany. And this is not something that I'm saying off my mind. This is real data being presented by implementation of robots and how it has affected it. And back again to the low robotic density in emerging economies or low emerging economies, like India, of course. You can see, of course, 12 robots has a huge impact on the country. So a big factory could replace all of their workers by 12 or, let's say, 25 robots, which is a lot. 25 robots working continuously are stopping in the middle just only for daily maintenance. So imagine you will have a lot of beneficial out of that, and also you will have effect on low-skilled workers. Since the country is filled up with low-skilled workers, you will have a huge impact on this type of skills. All right. Autonomous, on which basically sectors is being affected. We have automotive, we have electronics, and textiles. Textiles are clothes, basically, or let's say that. So, we're talking about how robots could replace these jobs. So in automotive, are there tasks building a car is replaceable by autonomous robots? Yes, by 64% of their job could be done that. In the manufacturer, of course, we're talking about. Electronics, 58%. Textiles, 42%. You know, robots could do that. So, jobs at risk. When it comes to automotive industrial building, there is about 3.2 of jobs at risk. But then it comes to electronics, we have 2.1 of job at risks, and then we have in textile 1.7. But there is a positive outcome out of this. You can see there is new roles have been created in millions. 1.8 million has been created, high-skilled worker jobs. And also we have in the electronics 1.5. You can see there is some sort of comparison between electronics. There was like 2.1 effect, and there is 1.5 being created. So if you did the calculation, about 600,000 has been lost their job. But that's still a positive thing. If the company, or I mean, if the country kept on emerging and implementing or teaching to have high-skilled workers, engineers, AI engineers, mechanical engineers, robotic engineers, anything that needs some sort of technological or considered as a high skill. We're only talking about technology from engineering side. We're not talking about medicine yet. So that is a huge different market that we haven't covered yet. And this is exactly what I'm trying to say here. So, which of these jobs or sectors, to be more precise, is automable or could be replaced by AI or robots, to be more precise? Telecommunication. Your customer service could be replaced by AI. Insurance pension management, also some sort of AI could be able to do that and book for you, check the details that needed, supply chain and transport. I was talking about it. So yes, it is being affected. Production of consumer goods. It's also something that is being highly affected by that and is growing more and more. Mining and metals, machines are going through that right now. You can see right now, if you implement two types of technology together, you can reach the result, whatever you want. But these are data that has been proven after our certain calculations. Results shows us that these are the sectors that are, or jobs are highly being affected. But there is something else. Governors or government and public sectors. Yeah, imagine you want to go renew your license, or you need to get some sort of birth certificate or something like that. It could be autonomously, but it needs some human verification, so we are not working on it. Medical and healthcare service. There are robots that are used for creating, but it's used by high-skilled, of course, doctors. So it's not replacing that anytime soon. It's a very sensitive job, and it cannot be replaced easily. Automotive and aerospace. So here it's a bit, you know, as the result shows that automotive may not have lots of effect, but we're not talking only as specific, we're also, there's a combination of aerospace also, which is space engineering, cannot be implemented only by robots. Could be some sort of sections of the aerospace could be replaced by robots, but not all of them, and that's why it doesn't have a huge impact on it. And the percentage is very low, highly visible. All right. Okay, so reskilling for workforce adaptation. So, how can you prevent the outcome, the negative outcome of implementation? So, the goal is equipping workers with skill of technology-driven labor market. So, we need to equip these workers with a high-skilled job. Of course, technical training in robotics field, and it should have about like 60 to 50% wages, premiums for certified workers. For example, of course, we have in Germany, they have done so, and they have implemented by investing about 10 billion euros and 10 billion euros, and of course the productivity and retain gains for all of that is about 5 to 10%, which is a very good percentage. And of course South Korea right now is working on and implementing some sort of robotics and AI training, and of course is boosting labor ability to be ready for the far future. And this is very sensitive part. Policy. Policy is very important, and you cannot have it not been done. It's very important so that if anything happened or implementing some sort of robot could affect the low labor, there should be some sort of policy. There should be some sort of rules that needs to be implemented before implementing robots. So in order to do this, this and that, in order to replace 10,000 workers, you need to show that the positive productivity of doing so is by implementing how many robots, and that's how it's going to be a positive and negative, and there's some sort of a policy that could be created to be able to prevent huge losses when it comes to the low-skilled workers. Short-term working scheme to to preserve employment, reduce job losses during the economy and autonomous disruption. So basically is to reduce it as much as possible. Germany, for example, has 1.2 million jobs preserved with fewer than like some sort of 15% to 20% fewer displacement in the manufacturing section. Of course, mechanism is to employers reduce working hours, governors are income loss or avoid layoffs. So this is some sort of policy that should be implemented in the economy, not to support or supporting a country increase by implementing robots is something good, but also you need to make, accountable of the other people that are actually being affected by that. And policy recommendation is limitation is less effective in emerging economy with large information sectors. So of course we talked about that. Some sort of countries are not benefiting so much from implementing robots as they're losing more workers, more cheap labor. Sorry for saying the word cheap, but low-skilled workers to be more precise. And it's affecting the economy because a lot of people are losing their jobs due to this. And policy adaptation in short work programs to autonomous driven and displacement expand coverage to vulnerable sectors. So sectors that are very vulnerable and being replaced by autonomous needs to be having some sort of policy to protect them and save them for the far future in case of anything of implementing robots could affect them. Tailored strategy basically addresses the very automation exposure about the across of these sectors. And for example, in Vietnam, they have preserved about 8,200 jobs. And these jobs are, for example, each worker, low-skilled worker, cost about $1,300 a year. So by preserving 8,200 jobs, the government has preserved this amount of money to sustain these low-skilled workers or keep them in their jobs, not to let them lose it while implementing robots. Of course, the positive way to decrease the number of displacement is to increase education and courses to allow these low-skilled workers to at least have some sort of technical understanding and able to implement or help in maintaining these robots, because this is something will be later in the far future as a mid-skilled worker maybe. So they need to be shifted a little bit up, let's say, from low-skilled worker to the mid-skilled worker, since mid-skilled workers are actually in the middle. And of course, wages increase, targeting training, jobs, and creation. So if the more courses you have implemented, the more you will be able to not be replaced and have enough technical information to do so. Investment in robots and retraining, of course, we talked about that. That's in the healthcare situation. And of course, policy recommendation, design industrial specific automation policy that combines wage, training, innovation, and support. Okay, so we're getting by the end of this lecture. How long have we been going? Ah, wonderful. To the people watching right now, my apologies, I'm a bit exhausted, and it's a bit late. So let's get to the let's cut to the chase, to the right way to say it. All right, so. Study limitation. Our research paper has some sort of limitation. And the limitation is that the data that we have obtained is public data. And there are companies that provide us with private data, but we thought about the best way to create a research paper is to provide information using public data to have the audience or the public audience to be able to access this information and find the result themselves. Okay, so measurement and challenges skilled classified basically when we went to the OECD, they totally ignored the mid-skilled workers. We tried our best to try to implement them within our calculations, but they were kind of, neglected. They were only focused on low-skilled workers and high-skilled workers. And of course, the problem is that we also have some sort of limited or a small scope. The thing is, from the results, as you can see in the previous, we showed in the previous graphs that there was a slight increase and it kept increasing, and then it started sustaining and going down. So we are not yet, due to the research that we have right now, we are not 100% confirmed what is the final outcome, or we need a huge data or longer time a period of scope to be able to specify or be 100% sure and have our p-value the reduced as possible to make sure that implementation of robot will in the far future have some sort of, or is going to be continuously having positive effect. Also, if you have everyone is high-skilled workers and all jobs are being autonomous, that means we're only pumping high-skilled workers, and then high-skilled workers may not be able to find a job because everyone is high. Of course, it's impossible, but this is a theory, basically. Then who is going to be working, you know? So we still don't know. We are, this is the coverage of data we have found. And sectorial coverage, we have focused on manufacturing and services of goods and sectors, but not healthcare, because this data has not yet been provided for us. So we are not yet sure about the data that's been provided. Okay, so the future of this research. So as you can see right now, our paper is more talking about generalized or globalized. Our future in the research with me and Dr. that we're going to be focusing on is the impact on each sector, basically. And nicely that we have done so, we recently presented a paper which is Autonomous Mobility in Qatar, Technical, Economic, and Financial Analysis for Robotaxi Integration. Qatar right now is one of the emerging economies, and they're implementing right now autonomous vehicles. And this is the beginning that we wanted to start. As we said previously, we did a global search, but to be more precise, we need to make sure the positive and negatives of implementation of autonomous vehicles, robots, what is the effects of them. As you can see, this is more of a more micro or more emphasized exactly on the robotaxi, as Qatar right now implementing autonomous vehicles. And as you can know, autonomous vehicles will be replacing also low-skilled workers. I'll just give you some sort of conclusion, not conclusion, or like overview. Qatar implements by importing low-skilled workers. This is something that later on will affect the country positively, as they will not need to implement or introduce low-skilled workers from outside, and they will have only high-skilled workers that will be maintaining these autonomous vehicles. So this is some sort of conclusion of this paper. And of course, we talked about how is it possible to implement that, and will it be really beneficial? Because of course, there is some environmental effects due to the temperature and everything, and these are technology that are going to be working some sort of a very hot weather. So it has positive effects, but at the same time, will it be able to sustain these positive effects to the economy? So, conclusion of our lecture today about the research paper that we have conducted is by each 1,000, by each additional robot has been replacing 1,000 workers. So it has, we have seen that there is an increase in productivity. Employment and wages polarization, we need to focus more on giving priority to some sort of workers, but also we can see the effect that high-skilled workers are gaining more money and low-skilled workers are actually losing money due to this, are being their wages are being affected by the implementation of robots. And of course, advanced economy, as we can see, of course, the regional effect is as advanced economy is benefiting while they have more high-skilled workers, and we have low or still emerging countries are affected some sort of positively, but also highly negatively due to the high skilled workers over there. And we need to focus on that paper also is talking about the policy implementation, how we should, you know, create some sort of equalize policy that does not have some sort of effect, but also some countries is actually implementing that. And final takeaway, automation is not destiny. Something has been written. But what I'm trying to say is autonomous vehicles is going to happen. Autonomous robots will be implemented. Humanoids are coming. All of this is happening at the meantime right now. We shouldn't be ignorant towards this information, and we should be more highly aware of our upcoming future, and we should focus on that. This research, the reason made me and Dr. Edu try to emphasize or do it basically is that we were talking about artificial intelligence, how it has its negative and positive effects. So right now, since my specialization is focused on robotics and economy effects, we started doing these research papers. And we are done. That's it. Thank you all.